Hi, everyone. We're very excited to see you join us in this session about the ArcGIS Maps SDK for JavaScript. Yep.
Thank you for that feedback.
Yep. Can you hear me? OK, awesome. My name is Max Prettier, and I'm a developer on a JavaScript team. I mainly work on widgets and web components. And today, presenting with me is Noah Saga.
Hi, I'm Noah. I'm a product engineer on the JavaScript team with Max, and I work on several different areas of the API and SDK.
Yeah. We have seen many developers create amazing applications with the power of the Maps SDK for JavaScript. And so the purpose of this presentation is to set many of you on the path toward creating such amazing applications. The session will mainly focus on the developer-facing aspects of creating mapping applications. And the tips and tricks we will cover today are generally applicable in web development, but we will talk about them in the scope of jsapi. Here's a brief overview of what we're going to talk about today. So we're going to start by talking about how to set your development environment for maximum productivity and efficiency. Then we will cover some of the most important tips and tricks for efficiently debugging your applications. In the process, we will go through some of the most important features in the browser DevTools, as well as briefly mention some of the exciting developments in the AI-based features and AI-based tools that could really be used in your debugging. Finally, Noah is going to take over with a great introduction to tips and tricks for ArcGIS Maps SDK for JavaScript. He also has a selection of most important resources you should be aware of. Unfortunately, due to time constraints, we cannot mention all of the great resources we have. So at the end of the presentation, we will make sure to provide the link for those who wish to dive deeper. The link will contain resources for every topic we mentioned today. So if you're interested in learning more information, please follow the link we will provide. So there's a lot of information we're excited to share with you today. So let's get started. And we're going to start by talking about how to set your development environment. And doing so is important because as a developer, you will be spending a lot of time in your editor. So configuring things correctly could save you a lot of time in the long run. If you already know which IDE you prefer, that is awesome. Otherwise, VS Code is a great choice. Let me show you some of the most important things you should configure in a good editor. Probably the most helpful tool would be code formatter, because with a code formatter, you can let it take over the spacing and indentation, let it handle all those things for you. And so then you only have to worry about the content of your code. You don't have to make sure to follow the indentation on your own, because a good formatter can make your code look pretty for you. On these two screenshots, you can see both samples of the code use our newly introduced map components. You might have seen them presented at the plenary yesterday. And even though the both code samples have the same code, the code sample at the bottom is far more readable and nicer to look at, just because it's properly formatted. And so it's really cool that a good formatter can take care of all of that for you. Prettier is by far the most popular code formatter out there, and it comes pre-installed in many editors. Though in case of VS Code, you do have to go into settings and say that you want to auto-run it automatically whenever you save your file, because that way it's even more convenient. Your file is always properly formatted. Next, code quality becomes really important when your project grows. And while good code is hard to define, in general, it's the kind of code that is easier to understand for your teammates, easier to understand for you in the future, and that is easier to maintain as your project grows and some changes are required. ESLint is by far the most popular solution for enforcing good code quality. ESLint is a bit like having an experienced developer behind your back, giving you suggestions on every line of code as soon as you typed it. And these suggestions are context-specific and really helpful for guiding you through what are the good code practices. You can see on this example, we have on line 1 a variable we declare, and we never modify it. And so in JavaScript, when you intend to declare variables that you never modify, you can declare it using the const keyword. And this way, anyone reading the code would have a clear indication that this is like a configuration variable. It's not intended to be modified. And so that's what ESLint suggestion is showing us, that we could declare it as a const instead. And later on line 13, you can see that we are comparing the value of the variable to itself, which is a potential bug. And so ESLint is giving us a warning that this is potentially not a good thing to do. And so you can see just like that, ESLint can give us helpful code improvement suggestions, as well as detect some of the possible bugs. The especially cool part about ESLint is that many of the suggestions it gives us are auto-fixable, and you can just apply the suggestion it gave you by clicking on the quick fix button you see on your screenshot. Or you can use a keyboard shortcut available in many editors that will automatically fix all the suggested changes in a given file or even entire directory all at once. Now let's talk about your development workflow. And when you develop your application, you're probably making some changes in your editor, then saving the file, going to the browser, loading the page, checking if changes look good, and if not, going back and starting the cycle again with further changes. And this cycle may repeat many times per day, so we can make it a bit more efficient. What if, as soon as you save your file in your editor, the web page in the browser updates automatically? That would be pretty cool because it can save you a few precious seconds, which adds up. And there are many tools that can automatically reload the browser page when you save changes. One of such tools is called Live Server, and it's an extension for VS Code. With that extension installed, you can just click on a button in your status bar in your editor. That starts a server, and then on any edits to the HTML file, the web page will automatically update in the browser. That is pretty cool, but we can actually do even better. Modern build tools like Vite and React support a feature called hot reloading. And what hot reloading does is, when you make some changes in the code, it will automatically update parts of the web page that changed, while leaving the unchanged parts of the web page in place. So in practice, that means that you get to see the updates much faster, since you don't have to wait for the entire application to load, as it dynamically only updates the changed parts. And you also don't lose your context, like you don't lose your console log or your scroll position. So it's really great for developer productivity. And whether you're working alone or in a group of developers, keeping track of your code changes is really important, because if you keep track of your code changes in a version control system, it becomes very easy to see who changed the code, when, why, and what other changes were made around the same time. It's also very helpful that if you keep track of your code changes, and then if you have a reason to revert some change because it introduced some bug or it changed your opinion, with a version control system, reverting changes becomes very simple. And probably the most important reason to have a version control system is that it prevents you from accidentally losing your files, your code. I can share a story from my personal experience where 6 years ago, I was working on an e-commerce project, and it was due to be delivered soon, but then I accidentally deleted a week worth of work, and I had to scramble to write it all back in just 2 days. It was like from morning till late evening. I was able to write it on time, but it's a stressful experience, so I would advise all of you to use a proper version control system on every project. Git is by far the most popular version control system out there, and it's often paired with GitHub for hosting Git repositories. Unfortunately, Git is not the most approachable from a beginner from a command line, but that's why we have several visual interfaces for Git available, so if you prefer, you're free to use those. One example is an extension for VS Code called GitLens. And on the topic of VS Code, we also have an extension called GitHub Pull Requests and Issues that integrates VS Code with GitHub better. And now comes my favorite part, and that's TypeScript. As soon as you start working on a larger application, you will find TypeScript really helpful because it can catch your bugs before your users do. That's a really important thing, and TypeScript does it really well. The way it does it is that it adds optional type annotations and type checking to your JavaScript application. And what that means in practice is that if you have some bug or error in your code, oftentimes TypeScript can catch that error as soon as you typed it in your editor. So you see the warning message in your editor right away, or you see some kind of error when you try to build the application. In either case, oftentimes the bug gets prevented even before the web page is opened in the browser, which means the bug is caught before it affects your users. Let me show you how that looks like in practice. Let's say we have a code sample where we have a function called createMap that, given some arguments, creates a map view. And then later on, we call that function on line 14. You might notice that this looks like a pretty much ordinary JavaScript code, but on line 5, we don't have just the argument names, we also have the argument types. And types is what TypeScript brings to JavaScript. It adds type safety. By adding these small type annotations, TypeScript can then check that every place where we call this function, we provided correct arguments in a correct order of correct type, and that all required arguments are provided. So it's a lot of safety provided. And not just that, TypeScript also checks that whatever value our function returned, that whoever called our function used that value correctly. So for example, if you have a function that returns a string, TypeScript is going to make sure that whoever called your function is not trying to treat that string as a number without first explicitly converting it. Similarly, if we have an object, and TypeScript is going to make sure that nobody's trying to access a non-existent property on that object. That is really helpful for preventing typos. For example, here on line 21, I tried to call a when method on a map view, but I made a typo. TypeScript not only detected the issue, but also gave me a suggestion about what is the most likely method I meant to call. And as a reminder, this error message, that's what you see in your editor as soon as you type something. So it's even before you get to an error message in your browser. So it's really helpful. Even better, TypeScript doesn't just check your application once, it does it continuously on any change. So for example, here, I refactored my createMap function to move the container argument to be first, because it's an important argument. And just like that, TypeScript is able to notify me that on line 16, I should also reorder the arguments to match the new function signature. In this case, it's pretty simple to not forget to update that usage of the function, but imagine a large application where you have a function called across many different files. Having TypeScript catch and notify you when an update is needed to match the new function signature is really important for giving you confidence that your changes did not introduce any new issues. Even better, since TypeScript knows that much about your application, like it knows the files you have, the functions, whatever objects you have, what are the properties on those objects, it can use that information to provide much better after completion in your editor. Which means, let's say I want to call some method on MapView. TypeScript is going to make sure that as soon as I start typing the method name, it's going to filter down the list of possible methods on MapView to just the valid options, like the methods that actually exist on MapView. And so then every suggestion I get is a valid method that I can call on MapView to get some value. This is great for developer experience because the suggested code that you get with TypeScript is much more accurate. And the ArcGIS Maps SDK for JavaScript itself is written in TypeScript. So we provide great developer experience when you use it in TypeScript applications. And to get this kind of developer experience also in your applications, where you get type safety, type checking, and other benefits, you should try writing your application in TypeScript. If you're interested in getting started with TypeScript, we have awesome starting guides and sample code for you. And we're going to share those with you at the end of the presentation. But now let's shift to the next major section of today's presentation, and that's on how to effectively troubleshoot your web applications. Each browser ships with extremely powerful development and debugging tools available. They're commonly called DevTools. And while you probably know that you can use them to debug your application, you can actually do far more with them. You can use DevTools to inspect page styles, inspect network requests, test your web page for accessibility, and identify performance issues. So in the next few slides, I'm going to go over some of the most important capabilities of DevTools, starting with debugging. The basics of debugging is you can set a breakpoint on some line to temporarily pause your application. So in this code sample, I opened the sources panel in my DevTools, and that lets me see the code of the application. And then by just clicking on any line number in there, I can see the breakpoint is being set on that line, for example, 45 in this case. You can see that in this code sample, I set a breakpoint inside the event listener for when the view becomes ready. And once the browser executes that code, it's going to stop on that line, letting me inspect the state of my application at that moment. To do that, it's very simple. You just hover your cursor over any variable in your application, and you will see the value of that variable at this moment. You can also use the console you see below the source code. In the console, you can type any JavaScript expression or just a variable name, and you're going to see the value of it right away. And from this point on, you can either step through your application line by line to see how it computes, how it executes, to see if it looks correctly, or you can just resume the execution and let it go through like it would normally do. And to make your debugging more powerful, besides just regular breakpoints, we also have other types of breakpoints. For example, we have Logpoints. Once you have a regular breakpoint, we can convert it to a log point. And a log point is like a console log, but better in several ways. So if you have a regular breakpoint, to convert it to a log point, you can right-click on it. And from the context menu, you can select Edit Breakpoint, and then change the breakpoint type to log point. That gives you a text box where you can type some kind of JavaScript expression. And now every time this log point is hit, you're going to see the expression being logged to the console. In this case, I put a log point inside a function called popup template content. And in my application, when the user clicks on any feature on the map, the popup is going to be displayed. And this function, popup template content, decides what is the content of a popup for that feature. So the function is called with the feature as an argument, and I can use a log point to log the feature name to the console. And now every time the user clicks on the feature on the map, I'm going to see the feature name in the console. Besides regular breakpoints, we also have conditional breakpoints, and these are really useful when a function is being called often, but you only want to inspect its behavior in certain cases, like under certain conditions, or if a certain argument is true. And conditional breakpoints are really useful for that. In this case, you can create a conditional breakpoint, and as a condition say, if feature name is equal to some feature, then stop my application. This is really great. For example, if your application is not behaving correctly for some one feature, you can use a conditional breakpoint to stop and inspect how it works, how it executes with this correct feature. But by far the most universal solution for finding a lot of errors in your application is a checkbox called Pause on Uncaught Exceptions. With that checkbox set, anytime there is any unhandled error anywhere in your application, the application is going to stop right away. It's going to stop on the line where the error occurred. And this is really great because you can see right away what triggered the error, what is the value of all the variables in your application at the moment when error occurred. And then you can also see who called this function where the error occurred, so you can see indirectly who caused the error to happen. That's a really great starting place for debugging where the issue is occurring and why. And besides just debugging source code, we can also do other types of debugging in your network tools. Network tools is a great place for inspecting network requests that your application makes. Whenever your application wants to load some data to display to the user, or to power features like search and querying, it makes a network request to your server, and the network tools is a place where you can inspect all the network requests your page makes. For example, you can sort each request by how long it took to complete, and this is really great for checking if there are some performance issues in the application. In this case, for example, none of the requests took even half a second, so it's pretty fast and you don't see any obvious performance issues. But a very important concept related to network tools is the concept of caching. Caching is something browsers do to improve performance for a user. When a web page makes a request for some resource, the browser may decide to store the response for that request locally on the disk, so that the next time your application makes that request, for example, next time the user loads your application, instead of making the actual request, the browser will just retrieve the previous response from the local disk. That is really great for improving performance, but sometimes that could cause some issues. For For example, if you updated the resource on a server, the cached value you see on the web page may be out of date because the browser is still using the response stored in the local storage. The disable cache checkbox is really great for temporarily disabling the caching, and so that will let you inspect the performance of your application and the behavior of your application with all the up-to-date data. You might notice that in my sample application, I have 115 requests made, even though I have just a small sample application. Let's inspect what are the individual requests that my web page makes. I can use the search box at the top to filter requests. For example, I put query in the search box, and this way I filter down the requests the web page made to just the requests that contain query in the URL. And that filtered down to just 6 requests. Now I can click on any request to see more data about it. In this case, on the payload tab, you can see the data that your browser sends to the server. And by your browser, I mean either your HTML page or your JavaScript file. So either way, the data you're seeing here comes somewhere from your code. And later on the preview tab, you can see what is the response from the server to this request. So this is really great for making sure that the data your browser sends to the server and the data you get back is looking good. One example error this could help identify is, let's say you have a search feature, and when a user tries to use a search, it always returns the same results. You can use the network tools to inspect what request does your browser send. Let's say you were able to identify that each time the request is sent, despite what queries the user typed, the request is always made with the same search query. That tells you that the error is likely somewhere on the front-end side of your application because it doesn't make a correct request. And just like that, you're able to narrow down the scope of where to look for the bug in half, because now you can look just at the front-end side of your application. You no longer have to look at the back-end side. And that brings us to really important tips and tricks for making your debugging process more efficient. When a program misbehaves, it could be tricky to figure out what's happening because a modern program may include many moving parts interacting in complex ways, and it could be hard to understand what's going on. That is why a really helpful suggestion is to try to rule out as many causes as possible, one by one, because this way you get closer and closer to a solution, and not just any solution, but a solution where you can understand what went wrong and where you have confidence that your solution is going to prevent the problem from happening again in the future. For example, I mentioned that you can use the network tools to make sure that the data the browser sends and the response it gets back looking good. And if you identified an issue on either side of that interaction, you can then narrow down the search for your bug to just half of the application, just front-end side or the back-end side. For other types of errors like state management or performance issues, it could be helpful to temporarily disable or comment out some parts of your application. And this way, they don't interfere with the debugging process, and you can rule them out as possible causes for the issue. Let's say you were disabling features in your application one by one, and you figured out that after disabling one feature, your performance issue no longer happens. That gives you a clear indication that that feature might have something to do with the performance issue. Or let's say you went through your process, you disabled a bunch of things, but the issue is still present. You're still in a better position because your application is now temporarily smaller and simpler, and so it's easier now to step through it step by step, see how it executes the code, and what might be causing the issue to happen. In some cases, it's actually helpful to go the opposite direction, where instead of simplifying your existing application, you just create a small sample application as simple as possible and try to reproduce the issue in that application. It could be just a small code sample or several files, and once you figured out what's going on in that small application, you can apply the lesson you learned to fix the issue in your real application. In the process, of course, it's very important to keep track of your code changes so that you can revert the application back to the known state if you identified that the issue is caused by a recent change you did, and so that you can clean up any changes you might have done in your debugging process. Now, kind of exciting is that you're probably aware that a lot of AI-based tools are starting to come out, and this could really be used in your debugging process to speed up your process and to give you more capabilities. You might have heard of tools like ChatGPT, Gemini, BinAI, and Claude, but the landscape is changing rapidly. In general, these tools can be used for things like explaining error messages, how to complete in code, giving you architecture suggestions, and giving you suggestions on how to resolve a given issue. These tools are only set to be more powerful, so you should definitely try to get experience with them now, because that will set you up for success in the workspace of the future. Of course, you should first check if it is against the policy of your organization to use such tools or not. And the final thing I have to mention is that whatever tools or frameworks you're using, you should check if there are extensions available for your browser or your IDE that improve integration with these tools. For example, if your application is built with React, you should definitely try out the React DevTools extension for your browser, because that will make debugging applications way simpler. Also, if you write your test in Jest, and you should definitely write your test, then you should try out the Jest extension for VS Code, as it will let you run the test from inside the VS Code without having to open the console. That's all I have, and now I will hand it over to my colleague Noah, and he will give you more great tips and tricks for debugging applications.
Awesome. Thank you, Max. All right, can you hear me okay? There we go. All right, the console is another great destination to head to in the developer tools for debugging. Here you can log your own messages, but you can also see warning and error messages from both the browser and from the JavaScript Maps SDK. You can see an example of a warning message on the screen there, and it's just showing that it's having difficulty connecting to a geolocation service, probably because the request is being made over HTTP instead of HTTPS. However, there's a bunch more cool things you can do in the console. Similar to what Max was talking about in the network tab, where he was interrogating some variables and looking for values, you can also do that in the console as well. On the bottom, you'll see a code snippet. This is printing out the current extent in geographic coordinate system. But there's one caveat with the console log statements, is that they're only going to run each time they're called. So unless they're being put inside a function, they're probably only going to run once in the application. So that means that we might need something that we want to see consistently in the console, and we can use something called a live expression. A live expression is really cool. It's like a console log statement that persists in the browser. And actually, rather than just tell you about it, let's actually look at an example. So here's a really interesting map, and I'm going to open up, I'm going to use the 3 dots up here. I'm going to come down to More Tools and go to Developer Tools. It's going to open up the console for me. And you see, I already have one statement here, but I want to add another one, because I can see the latitude, but I'll click the little eye emoji, and it says Create Live Expression. So I actually want to use very similar to this, but I know from my geography days that most places have both a latitude and a longitude. So I'll create longitude. I knew I shouldn't have done this live. There we go. And now we have a latitude value and a longitude value that if I pan and zoom in on the map, we can see these values update in real time. And I can even close the browser tools, and I can come back and open them again, and that same live expression is going to persist until it's actually removed. So this can be really helpful if you're looking for the extent of an application or how to actually center what specific value you want to use as the center in your application. All right, another neat thing you can do is inspect the color themes and inspect the CSS. So a lot of different users like to have, say, a light theme or a dark theme for their application. And you might want to see how your application looks with the light theme or with the dark theme, either so you can create rendering tools that are appropriate for either theme, or if you want to build in smartness to your application, you can actually detect the theme that the user is using, and you can actually test that out just by using the developer tools. So let's look at an example of that. We'll come back again. We're going to bring up the developer tools. But this time, we're going to come over to another 3 little dots, and we'll see there's even more tools that we can use here directly in the browser. So I'll come down to rendering, and then right away, we're going to see there's a whole ton of things that we can emulate in the browser for rendering. So we have a lot of options down here, and as we come towards the bottom, we can change the theming to be light or to be dark, and that way we can see how our application actually handles with those themes. Now, something else you can do with CSS is you can actually inspect styles. So I could even do this right here. We could right-click and inspect, and it's going to bring up all this information. Let's move this one down. And if we look for something with color here, we'll find something right down here. We can actually click on it, and we can expect the specific color value. Maybe we want something more red. And so we could copy this value so we can match the color scheme in our application to be what we've seen elsewhere, or we can define the exact color value that we're using so we can let someone else know about it. All right, something else you can do, you can also emulate location. Again, we're just using the browser tools, the developer tools in the browser. We can emulate sensors so that we can pretend that the device is in a specific location. This can be really helpful for testing out routing applications if you don't want to leave the office and go do the actual route. Or if you want to test the functionality of pop-ups, you can mock the location of a click event, and then you can test out how your application handles that. However, a lot of people use mobile devices these days, iOS and Android, and if you want to deploy even a JavaScript application on the web to be consumed by mobile devices, if you want to debug that experience, you need a physical mobile device. And as we all know, there's a plethora of devices out there, whether you're using iPhones or using Androids. But again, there's an easier way to do it. You can actually use the emulation tools in the browser to emulate a different network. So now we're all talking about 5G or 4G, but if you want to see how your application handles in a place with low or no coverage, you can throttle the network and emulate a fast 3G, a slow 3G, or even an offline application. But you can take it one step farther and say, hey, I want to see how this looks on different mobile applications. Again, they've got you covered. You can come right up here and you click on this little blue computer icon and you can change different devices. So here on the screen, you can see how the application looks using an iPhone 14 Pro Max. So that can be very helpful to see how your application will be used by customers on the mobile devices. All right, the last part of this section is accessibility. Accessibility is all about making content usable for everyone regardless of abilities. But what's really cool about accessibility is just going through considering accessibility can be really beneficial for all of your customers. So I'll just try to think of an example off the top of my head. Say you want to make a really stunning geospatial application for like a big software conference, but you work from home and you have a cat. Well, if your cat needs to be held while you're trying to make the application, you're only using one hand. So you're going to be using a lot of keyboard shortcuts and not so much mouse movement. So when a developer considers accessibility as part of the design process, they're going to have tools in there that are going to be good for everyone, not just for people that need accessibility tools. So that's why it can be a really important part of the development process. Now, there's a bunch of different accessibility tools out there. On the team, we happen to use these two. They're both freely available, Lighthouse and Wave. I'll just show you a quick example of what that might look like. So here's a stunning geospatial application. It's set in Chicago. And if I use the Wave plugin, I can immediately see that I've got some accessibility issues that I want to handle. So I've got some errors and I got some alerts. If you click on that again, you can actually get more details about how to fix these issues. So it's nice, it's a free tool. There's more complex ones available. But just to run this on your application, you can immediately see how you can make your device, or your application more accessible to everyone. All right, now this is my favorite section. This is the Maps SDK tips and tricks. This is specific to the ArcGIS Maps SDK for JavaScript, but it might also apply to some other products in the ArcGIS ecosystem. So the first thing is view events. So handling events is just like planning an event. Experience really pays off. And so we have a really nice application here. It's called the Event Explorer. And so what we do is on the right, you're going to see a bunch of events listed up here. And then in the lower table, you see a bunch of property values. Now, as I interact with the map, it's going to change and populate all these values. So if I just click and grab the Earth, you can see the top two blue ones. They're showing you the events that I'm interacting with. And the bottom part is showing the property values update in real time. Now, you might not want to make an application like this, but if you want an example of how to handle all these different events, this app can show you very quickly how the things are handled in the code. So it's a great starting point for learning how to handle events. And also, don't worry, all these slides are available right now. So after the presentation, we can share the link with you again. Another really neat thing is request interceptor. So request interceptor is part of the Esri config class, and it allows you to modify requests sent by the application before they're sent somewhere. So before they're sent to the browser or before they're sent to a server for resources, you can actually modify that request from the application. Also, you can modify that request before it's returned back to the application. So if the app makes a call to a server for resources, you can modify that request after it leaves the server, but before it comes back to the application. And I'll show you what this might look like. So this is a request interceptor that's being designed to work with a feature layer URL. So the first parameter you see is this URLs parameter. This means that any time a request is made with this URL in it, it's always going to apply this request interceptor. So you have to be careful. It's very powerful, but it's also very dangerous. So in this case, we're going to make a before modification. So before the request goes out to the server, we're going to say, hey, we have to make sure there's no max allowable offset on our data. So we have an if statement. If there happens to be a max allowable offset value, then we're going to set that whole gnarly thing to 0. So that every time our feature gets queried, it's always going to say, if you have a max allowable offset, nope, now it's 0. And that was important for the use case in this application. All right, let's look at some specific resources in the SDK, which is where I personally really like to live. So the first place to talk about is the JavaScript resources. So Max mentioned earlier about some TypeScript samples. We maintain a free GitHub repository where we can put all these cool samples that don't quite have a space in the SDK, and things that might be a little more weird, like some really interesting TypeScript examples that are a bit more on the TypeScript side and less just about the JavaScript story. So you can come to this repository and get some really cool resources, and we update this regularly. Another one on GitHub is Next. If you're not familiar with Next, it's the bleeding edge version of the JavaScript API. It's basically like, if you're familiar with Chrome Canary, it's our ongoing beta that's always the next version that's under active development. So it's a little unstable, and we don't recommend using it for production applications, but it's really cool to test out new functionality. Like if you had an enhancement request, it's going to come on Next first, and you can also report issues with the next version, and you can connect directly with the team, and we can look at it together. So highly recommend using Next. And the best part is to use it, all you do is instead of calling the version you're already working with, you just replace the version number with literally the word next, and it should work. Okay, my second favorite place in the SDK is blogs. So there's a lot of blogs in ArcGIS blog, and they're organized by different technologies, but we maintain our own curated list, and it's all separated by functionality. So if you look on the right here, you'll see concepts like 3D or arcade or labeling, and that's all the blogs on that subject that were written by our JavaScript team. Now, some of the blogs are going to be a little outdated, but the cool thing is not everything changes at every release, so a lot of the principles are still going to be relevant, even if they're a few years old. So if you're getting started with Arcade or getting started with map image layer, you can check out our blog section and find more detailed stories and use cases that can help you on your way. All right, my fifth favorite place is this little chart. Max was talking about components and talking about TypeScript, and we didn't mention the difference between AMD and ES modules. But if you've heard these terms before and they sound a little confusing, this table is really nice because what you use largely depends on what you need to do. So a lot of times people feel like they need to use certain technology because it's new, but the important thing is you want to use the things that are relevant for your work or that you're personally interested in. So if you're getting started, this table is a great way to start and just see which technology you should pick up and get running with. And this is my first favorite place. Actually, let's look at it live. Let's not worry about that. We'll come to the community page. So this is our community page on the SDK. We have a link for tech support, but what I really like is the additional support. So if you're looking for additional support with your application, we have these two areas down at the bottom. GIS Stack Exchange, Stack Overflow. These are free online forums. People can ask questions and post answers. There's a lot of good information there. Even better, if you're unfamiliar, is Esri Community. Esri Community is Esri's free community/forum, but it's more than just a forum for posting questions and getting answers. It's also a place you can raise enhancement requests with Esri staff. You can also post blogs, and you can make surveys and talk to other members in the community, and it's totally free. And Esri community staff, or Esri staff, regularly monitor the posts in the community. So you can get good help from other users like yourself, or even Esri staff will actually respond on there. So highly recommended. And then of course we have some free videos, and we have some Esri training classes. And if you have a subscription to Pluralsight, we do have a class on there. That's a great intro into the working with JavaScript. All right, but that's not the end of the story. We also have some related sessions. If you've enjoyed our time today, there's a session directly after us about the best practices for building web applications. Rene will be there. He's a real rock star. Tomorrow, we're promoting this customer session. If you're working with Angular, or if you're concerned about performance issues, this is a customer presentation that'll be taking place tomorrow from the folks at Patrick Engineering. Okay, and remember, please, we really do appreciate your feedback. We'd love to know what we did good. We'd love to know what we did bad. We'd love to make it even better for next year. So please share with us your honest feedback. And with that, I'm going to move back to the QR code. This should take you directly to our slides, as well as there's a link there as well. But we'll open the floor up for questions now. Oh, sorry, we'll pause for applause after you take a picture, and then we'll open up the floor for questions. I know people like when they know when to clap, because it gets all crazy in here. Oh, wow, oh, thank you. Oh, that's, wow. My goodness, they loved it, man. Whew. All right, so you're gonna have to raise your voices, or we can run the microphone, but I don't know if people wanna do that. No judgments. We have a question. Yes, sir.
All right, this is a dumb question. I'm still not entirely clear what the performance cap does in the Chrome developer tools. Think you could give me like a high-level explanation for a dummy like me?
Sure, I can do that.
Okay, good.
Repeat the question. Yes. So the question was, what does the performance tab in browser DevTools do? And performance tab in DevTools is a place where you can check how fast does your application execute a given action, whether that action is loading the web page, or like opening some menu, or like loading a different part of your application. And so in the performance tab, you can inspect what does your application do at any given moment. Let's say when your application loads, what does take the most time for application to load? Is there a specific file or some function that takes a lot of time to execute? And whether it's some issue in the JavaScript side, or maybe some rendering is taking a lot of time because you have like a complex table on your web page. So the performance tab is where you can inspect what does your browser spend time on during the given time frame. So you can improve performance and either optimize some JavaScript function or delay load some resources. And so on the performance tab in DevTools, you can start the recording at any moment. And once the recording is starting, you can do the action, then stop and see the result.
Thank you. And as a follow-up, could it also be used to check the speed of, say, re-renders using React state hooks, or use things like that, or would something else be more optimal for that?
Yeah, so the question if that can also be used for inspecting React hooks and React performance. That can indeed be true. So it contains the performance of any JavaScript function, and React is also would be included. But if you're looking for debugging your React application specifically, the React DevTools extension has a tab called React Profiler, and that is more directly for testing the performance of a React application. So while you can still use a developer performance tab to inspect the performance in general, if you're interested in just React and like focus on the React hook, React rendering, the React DevTools extension is really useful.
Okay, thank you.
And as a reminder, the QR code and the link you can see on the screen, that leads to all the resources we mentioned today. So additional resources for TypeScript, Maps SDK, as well as today's slides and notes.